Electricity is present in just about every area of our day-to-day lives. While it is generally safe, faulty equipment, overloaded circuits, and other hazardous electrical conditions can cause severe injuries or even death. It's important that you're aware of the electrical hazards on your site and how to work safely around them. When you have completed this course, you should be able to recognize how electricity works and common electrical injuries. You should also be able to identify common electrical hazards, recognize electrical safety devices, and identify methods for managing electrical hazards. Lesson 1. Recognize how electricity works and its dangers. Electricity is generated by the movement of electrons between atoms. A circuit is a conductive path that an electrical current can flow through. Conductive materials, such as copper or silver, provide little resistance to the flow of electrons, while insulators, such as rubber and wood, provide higher resistance and make it more difficult for electrons to move. The electrical concept of ground is a bit confusing because it can refer both to the earth and to the source of the electricity. But in simple terms, every electrical current is trying to find the path of least resistance to its ground point, and well-designed circuits use conductors and insulators to control current and direct it where it needs to go. However, all insulators have a limit to the amount of current they can resist, and that limit can be reduced by factors such as damage or moisture. If the flow of electricity is stronger than the insulator because the circuit is damaged or overloaded, electricity will break free and create an uncontrolled path back to ground. A fault occurs when electricity flows outside of its intended circuit. A short circuit is a fault in which the electricity flows outside the circuit with very little resistance. A ground fault is when the energy flows outside of the circuit back to the ground. Technically, a ground fault is a type of short circuit, but in electrical safety, the term short circuit usually means that the energized or hot wire makes contact with the neutral wire, giving a low resistance path back through the normal circuit wiring, while the term ground fault means the hot wire makes contact with either the ground wire or some other part of the equipment, providing a low resistance path outside of the normal circuit. Both are typically caused by faulty or damaged wiring. When a short circuit occurs, the low resistance allows more energy to flow through the system than intended. This can generate a lot of heat rapidly, which can melt wires, damage electronics, and ignite flammable or explosive materials. A ground fault can energize an unintended part of the equipment. For example, if a wire inside a drill comes loose and contacts the metal housing of the drill, the entire housing could become electrified and shock anyone who touches the drill. Most forms of electrical faults are also capable of producing sparks or arcs. An electrical arc happens when a powerful electrical current creates a path through the air, either to ground or to another conductor. As the electricity flows through the air, it will create plasma, which gives off an explosive burst of light, heat, sound, and pressure, known collectively as an arc flash. Tiny, brief arc flashes are called sparks, but sustained arc flashes with more energy can be incredibly powerful and dangerous. Lightning is a familiar type of natural arc flash. Arcs are sometimes created intentionally for applications such as certain types of welding, but when it happens unintentionally, we call it an arc fault. Both controlled arcs and arc faults can present arc flash hazards, including shock and burn hazards, explosion hazards, and hazardous amounts of UV radiation. Amperes, or amps, are a measure of the current, or volume of electrons, flowing through a circuit. Voltage, or volts, are the measure of electrical force pushing those electrons. Resistance is a material's opposition to the flow of the current. You can think of it like plumbing. The circuit is the pipes. Amps are the volume of water moving through the pipe, and volts are the water pressure, or how fast the water can move. The resistance of the insulator, in this case the pipe walls, is their strength, and ability to contain the water pressure without leaking or bursting. The resistance of the circuit itself is any buildup or blockage in the pipes, slowing the water down. Faults are like leaks or ruptures in the pipes through which current can escape.